It's one of the largest station roofs in Europe. It's nearly 150 metres across, so 1.5 running tracks. And we've got about 1,200 tonnes of steelwork just in the roof itself, and that's all supported on 16 columns. Each one of those columns has a load of about 600 tonnes coming onto it, so 60 London buses on each and every column. And you look at the roof and you don't think that there's those kind of loads, but we're designing for 100 years or more design life. So you're designing for the very worst snowstorm, ice loads, really, really high wind loads, and that all brings high loads down into your columns.
Engineering is a scientific discipline, but what engineering is that makes it different, it is making something a reality. And it does take the human interaction. And one of the key things is you need to, as an engineer working on the building sites, complex nature like this in the heart of London, is being able to make things happen, being able to deal with the human nature, take it forward, and not get hung up on personal issues. One of the greatest successes here was the fact that everyone worked as a team. I'm proud of the fact that we took something that was quite innovative in a station. The building behind was built in 1852, a grey unlisted structure, and we took this, and I'm proud of the fact that we took those challenges. We worked in Europe, went to Germany, Austria, to the Czech Republic, got a group of people together with the architects and the engineers, and were able to bring it to site. Every vehicle delivery, every welding piece on site was done with a very detailed planning of these key people. And to me, that's what engineering is all about.
I mean, in the very beginning, we're basically given a blank piece of paper. This site's got lots of constraints because we're surrounded by listed buildings, not allowed to touch them or put any load onto them. Underneath us, there's a huge underground station box for King's Cross St Pancras Underground Station, and that means that we've got very few options as a structural engineer of where to put our supports. So the curve of the Great Northern Hotel was what kind of defined our geometry. So what we did was just followed it round and bring it up, and when you get a dome, the dome's really, really efficient structure. You look at St Paul's and things, and but the problem is that we have to slice our dome in half because we've got the Western Range building slicing it. So we did lots and lots of options looking at how the dome geometry would change and the amount of load that we would need to take at this slice point. And we came up with this idea of adding a truss that's all the way down the face, and that resolves all of our forces, and we're not sitting any columns below.
We needed to always measure twice and cut once, and we did that by working in 3D. So we take the model from the engineer, we have to understand how the loads when it's built temporary can be withstood and how the structure can stand up. So when we build the structure, we have to ensure that it's safe during that temporary period as well as when it's in its permanent state. Part of that is understanding how it behaves. There's a lot of science that goes into the design, and as a contractor and the engineering, it's understanding what happens in that temporary state. These are the questions we ask, and it's quite often that that's where the challenges really come.
I mean, it's amazing. You never get an idea of what the scale or the size of this roof is when you're just seeing it on a screen. So the first time that I walked in here, you just come in and think, wow, it's even more impressive than I thought it might be. It's yeah, it's a really proud moment.
Part of the engineering that we bring to site from the contractor's point of view is to ensure that all the little tiny bits go together and they come to a point and fit on site, so there isn't any rework, and you don't really get a second chance. There's no rehearsal, and it's not a spectator sport. We must make sure everything works first time.
The real satisfaction is doing something, sitting behind a desk, and then in a couple of years' time you've got this physical structure that's seen by millions of people. It's going to be here for 100 years at least, and it's going to be seen by so many people, and I can just say, that was me. It's not just a meaningless result of the work that I do every day.